nice user experience oriented presentations. Let's go back a little bit to hardcore technology in a way. And as I titled, Revisited, there's a specific reason for it. Once upon a time, there was an innovation department and was thinking everything gets virtualized, so what about the SDB? That was 4.5 years ago. So then this Asterix and Obelix department of a big company ran to the technology department and said, hey guys, there's something new. What happened? You could have predicted it. Typical DevOps department says, oh, new technology, not proven. So we ended up with all those arguments and mythbusters about this technology approach to improve user experience on, let's say, more advanced user interfaces. So I don't go, you just get an idea. This is real world arguments we have encountered. Quite interesting, when we moved to our marketing people, they were happy. Oh, we don't need SDBs anymore, and SDB will always be cheaper. So there was a lot of optimism, but let's say not technology founded in a way. So that was quite interesting. Technology guys saying, oh no, in 10 years perhaps. The marketing guys saying, wow, why not do it? So this was, let's say, quite interesting. So what happened in the 4.5 years? It was the eternal battle of the innovation unit for a paradigm change, how you deploy set-top boxes. So I just collected some nice, interesting comics on it. But anyway, it reflects, I think, quite seriously the situation we had in Deutsche Telekom, convincing our technical and business units this is a valid technology paradigm to be implemented. So actually, when we look back, what promoted the turnaround towards, let's say, broader acceptance of those virtual SDB, or more precisely, cloud browser-wide technology? I think we have 6 factors coming into play. First is it's an IT paradigm shift we are seeing, so telco shift to infrastructure-based or cloud infrastructure-based production models. So it's also opening up the mind of the technology units that cloud is a relevant factor in future production. It's a broadband evolution, of course, that the customer reach with broadband is improving, and at the same time also low latency and bandwidth you have. Customer demands, for sure, in the last 4 or 5 years, continuous increasing UI performance, user experience demands, even on old set-top boxes. Business challenges, I think this is very important, what we have seen in the last 4 or 5 years, because we need to keep pace with the OTT players when it comes to service innovation and time to market with these innovations. If I see the traditional set-top box cycle, 1.5 years before you put something new on the market, this is too slow, for sure. Technical challenges, I think we have clearly seen, if you look, I come later to it, to a traditional operator, he is stockpiling boxes. That means you have to entertain very different UI versions, and that means a lot of testing, regression testing, and it means a lot of cost and time before you can output new service features on all your boxes to all your customers. And last but not least, I think very important, maturity of the cloud browser technology. It took also time, I think, that it matured and became carrier grade in a way, and so that carriers also got an idea that could scale in a way if you use that technology, and also the capability that such technology is also compatible, let's say, with OpenStack-based cloud infrastructures deployed by enterprises or telcos. So I think this is more the factors which, let's say, led to broader acceptance. So if you look at a typical telco situation today, I think what we see is an aging set-top box portfolio. So we have quite a zoo of set-top boxes collected over the last 9, 10 years, millions in a way. Usually a set-top box stays home in the customer 6, 7, 8 years, so easily. So it's not the OTT customers who are willing to buy every 2 years a new box, so I think they have a lot more conservatism. And due to that zoo of set-top boxes, we have a very fragmented user experience when we push out our services. Now, on an 800 MIPS box, it's a different experience when you have a 10,000, 15,000 DMIPS box. So how to deal with that? And of course, I mentioned it already, the slow innovation cycles and the complicated rollouts if you have a multitude of different client versions for your user interface. So this is still a valid, let's say, strategic problem situation for most telcos when it comes to TV operations. So we think that the cloud browser model has a lot of advantages in a way because it decouples more or less the user experience from a given hardware. And the good thing is you can deliver a constant user experience over a very, let's say, fragmented device spectrum of set-top boxes or other devices. That's a good thing about it. Technically, I think the architecture of a cloud browser, if you see here, is quite easy. There's a media pre-processing module, there's the application engine, there's media adaptation, DRM modules, and of course then the streaming engine, which is all combining that to an output to the device. Actually, what happens with CloudOI streaming is the set-top box or the connected TV receives either a video stream, the user interface is streamed as a video, or it's streamed as pictures. So this is the two opportunities you have to do it. I come to it later, what are the pros and cons for it. Key for using cloud browser UI delivery technologies is latency. This is the key factor determining whether the user experience is bad. So if you have a network which has latency problems, then there might be certain limitations. But what we found out, that if you can stay below 400 milliseconds, you are on the safe side. And I think in most broadband networks that shouldn't be a problem staying under 400 milliseconds. The lower you get with latency, the better of course, but we found out in several tests, we also took it to one of our, let's say, really stress tests in Greece, which is, let's say, at that time not known for very efficient aggregation network, but even there it worked perfectly. So customers really said, no problem, it's better than the existing set-top boxes, faster. So this is key. Stay under 400 milliseconds and you're on the safe side. Also very important to know with that technology, there are basically two approaches. It's a single stream approach and the double stream approach. Single stream approach means you mix the content stream and the UI stream into one single video stream. It looks, let's say, easier than the double stream approach, but the disadvantage is you have to re-encode the content again, and that means you waste a lot of IT resources by doing that. Because the content is also encoded at the head end, then it's encoded again with the UI and then delivered to the customer. It's not very economically in a way. It might be suitable for certain situations, but in practice, it's a very uneconomic approach. So the real economic efficient approach is the so-called double stream approach. That means at the set-top box there will arrive two streams. One is the untouched content stream and the other one is the UI stream, either in pictures or video mode. And then you mix it in the box when it comes to overlays and so on and so forth. So that means you only encode and you need CPU resources for the UI stream, not for the content stream. And that works also, that is a good thing with traditional legacy networks. So you can also use your multicast still to deliver the content in a way. It's going to be untouched. So just as a reminder, this is more or less the favorite, or let's say the favorite approach today. Another tricky issue when you go to cloud browsers, when it comes to content protection, is how to EME, encrypted media extension, is, it's possible, of course. but actually there are two approaches currently, and one is using a so-called DRM bridge approach. That means the end-to-end security is interrupted by the cloud browser, and that means an additional encryption is required. And that means, in a way, this might cause certain problems with the studios when the cloud browser is not a really trusted environment in a way, because it's a virtual appliance. So that might be tricky in a way. But anyway, it's good for legacy DRM. So if you need to integrate legacy DRM, it's a valid approach, but the complication is re-encrypting all the content. The more favored approach is using a distributed EME architecture for that. That means the EME is mapped at the same time on the server side, where the cloud browser sits, and also on the client side in the box. And then, of course, you have a very, let's say, Hollywood-compatible content protection solution. But this solution won't work for legacy. But everything is moving to browser and EME, so I think it's quite clear where the direction also for a cloud browser has to go. And getting out of trouble with Hollywood, I think the first approach is more, let's say, a temporary workaround perhaps, but in the end, you have to go for the second approach as a distributed EME architecture. This is very important to know. You have to take care of this too in a way, because we are running protected content also through the browser. Another thing we experienced in the 4 years, everybody thought it's either local execution or it's cloud execution. We don't think it's a black and white choice. We also had to learn this innovation because we think it's a continuum of a dynamic option space you have at hand. So I put it here in a more simple term. So what you can do as a first option is full UI streaming via cloud browser. That means either you go to the picture-based mode. That means this approach is suitable for slower broadband networks. But it's depending on the solution of the providers of cloud browsers. You can also, which is interesting, put animations even into the picture-based mode. So it looks like an HTML, CSS animated user interface. The other way is if you have enough bandwidth in your aggregation network, you can go to the video-based mode. That means you take the HTML5 or whatever kind technology is based UI and just stream it as a video. You don't have to touch it. So it saves a lot of time. And then there is what is interesting, so where we are also starting now as Deutsche Telekom is what we call the hybrid UI streaming approach. So you do a kind of flexible mix. I just put two situations down. So you can have a full local user interface on the SDB natively programmed. The basic menu is a native programmed on the box. And you do part of the services which are resource demanding, like a VOD catalog with all the posters, which usually a slow box would be very cumbersome to display. You put that on the cloud browser and stream it. So you mix local native UI with cloud browser technology, and then you can also decide whether you do the VOD posters in picture mode or in video mode. So it's also further options you have to play with. Another second part I put down is you also put only partial parts of the UI on the box. So partly very basic things in native programmed, more complex part of the UI, which are animated perhaps. It could be an animated EPG, for instance. You just cloudify. So that means also then with the services, you can decide all services are streamed from the browser or also go for a mix. So that means here you have quite, depending on your situation, where you are, what boxes you have, you can mix this technology in a quite interesting way according to your needs. And I think this is very important to know. It's not a black and white decision. So you have a flexible continuum to play and upgrade. What's also interesting is cloud browsers so far, although it's browser, but if you look at vendor solutions, they have a lot of proprietary elements in it. And what we as an operator like to see for cost efficiency is, of course, more standardization in vendor solutions. So there are two important trends currently, or let's say standardization activities. One thing we think is very important, you still need, even doing cloud browser, you need a thin client on the set-top box because you need communication. The thin client on the box needs to capture your remote control commands, send them to the cloud browser where it's processed, and then it's sending back the result. And this thin client is vendor specific until today. So either you have to go with AVN client, you have to go with an Entrex client, you have to go with a X and Z operator client, which we think it's complicating things. It's just a tiny piece of simple, let's say, software, because I think the real competition between vendors is about the efficiency of their back-end solution and economic scaling. So why not standardize this client? Actually, this is happening currently. There's a so-called W3C cloud browser task force, which is part of the web and TV work group in W3C. And they're working on a standard client cloud browser API exactly for this. So I mean, when it comes to boxes, you take this standardized client and can interface every kind of vendor solution without changing every time the thin client for the cloud browser. So I think this is very important in order to get to more decoupling the front end and the back end of a cloud browser solution. Second activity, which I just touched, but is very important, it needs further standardization, how to integrate MSE and AME into the cloud browser. We need it for playout, and also the W3 Cloud Browser Task Force is working on it. So hopefully this year we will see first results. But last but not least, operators are always wishful. So we have two other items which we would like to see in the future in order to make that solution more reality-proof. One problem, especially related to content provider, is currently in the cloud browser you can't have persistent cookies. Because this is a problem, for instance, for YouTube. Because they are earning money on reading out what is stored in the cookies and then supplying advertisement and some other stuff via the YouTube. So in order to convince, this is a long talk with YouTube and Netflix we have, because these are the most prominent providers currently refusing to accept this cloud browser technology. YouTube's argument is, I don't know what's happening and what the user is doing. I need it in order to remonetize my YouTube service. So this is really what we need in order also to get acceptance of in strategic content providers in order to deploy this technology on set-top boxes. Because then you also can have, let's say, a very superior YouTube experience on a 10-year-old box. No problem. And Netflix is a different story. It's not a cookie problem. Netflix likes to go the expensive way in guaranteeing their superior user experience. So it means even on our new boxes, which are 15,000 MIPS boxes, they do a separate integration based directly on the Broadcom API layer in Nexus, which is crazy, because then we have to switch permanently. If you call the Netflix apps, then the execution environments get shifted. Crazy. Doing it via streaming would be much easier. A second thing we think, which is important, which we discovered through work with one vendor, Entrex, is if you do the picture-based mode and animations, that means currently injection of proprietary JavaScript code. And that means you have to entertain two UI lines, which kills a little bit the economics of that approach. So we also think that this JavaScript language for inserting animation in picture-based mode, which a lot of providers will use, should be standardized. Because then you can easily maintain the UI. This gives you, I think I just don't touch it, some ideas about bandwidth requirements in certain use cases, UI streaming, application streaming, casual TV games. So it gives you an idea of what bandwidth is involved when you use that technology. So think out of the box, because we see the advantages. That means cloud browser technology means enriched constant user experience. It means faster time to market, because you forego all that complex regression testing of new features. It has money-saving potential, for sure. And the technical feasibility, I think, is confirmed by now. There's still some questions. And if you look what happened in the last 4 years, you see already that some major providers have already deployed this technology. Kata, SK Telekom in Korea, Liberty has done it, Cablevision has done it, and also CG Hellovision, Korean subscriber. SK Telekom, for instance, is converting its 2 million subscriber base totally on Cloud UI. Already converted are 1.3 million, and CG Hellovision is also 1.8 million customers already on cable boxes. And I think Liberty and Charter are also going up in the number. So it shows the technology is more or less accepted. So coming to the end, takeaways. I think this technology really bridges the gap between web development speed and device capabilities and delivers a really constant, superior user experience, even on 7, 8, 9-year-old set-top boxes. Really good. Deployment of a cloud browser solution means it's not a black and white decision. You have a continuum of options. You start little, and then when your DevOps department gets more, let's say, experience with the technology, how to scale, you put more service features on the cloud browser. Third, there's a strong need for further standardization in that technology, especially for the local client, the thin client, which communicates with the cloud browser. So that should be really standardized by W3C. And this, let's say, makes it easier that the vendors, the cloud browser vendors, focus on their core competency. That means providing an efficient, scalable backend for the cloud browser. And fourth, very simple, if you're a TV operator, just consider it as a key part of your future strategy for agile service innovation. That's it.
Thanks, Randolph. We've got a couple of minutes for questions. If anybody has anything they'd like to throw at Randolph. People are very quiet today.
Yeah,
oh, there's one at the back there. Could you introduce yourself, please?
Okay, my name is Arjan Koster. I work with KPN. I want to thank you for this real interesting presentation. I think it was so clear. I have no questions, but my compliments.
All right.
Actually, we decided now for commercial deployment of that technology. So it's targeted to be going before customer first quarter of next year. So the commercial deployment decision also for Deutsche Telekom has been made. And we will start in a kind of mixed mode.
That was actually going to be my question, at what stage Deutsche Telekom at. So.
Finally, our units have faith in that technology.
The checks have been signed? And
yeah, nearly.
You look surprised.
No, there will be a procurement phase next month, and after that, it's going for...
Well, with any luck at next year's Connected TV Summit, you can give us some feedback on from the real world.
Yeah, sure.
I just have one quick question for you. This whole business, we're talking about your households having to be broadband enabled here. And there's a lot of discussion in many countries, even in Europe, certainly in the US, about the reach of broadband. Okay, you know, we may be at 90, 95%, whatever capabilities in many European countries, but I mean, that reach issue, how do you reach those last 5, 10, 15% of homes? Is that required here, or is that a concern?
No, not really, because your TV customers are already, let's say, on a minimum of broadband, otherwise they won't get the content, let's say, except satellite distribution. So if you look at our footprint in Europe, the weakest NatCo has broadband means 6, 7 Mbit. So this is really fast broadband in one of our weakest NatCo, compared to Germany, which is now switching to vectoring and going further up. But the beauty of that solution is If you have 6, 7 Mbit, you can't make it with the video-based UI mode, but you can make it with the picture-based mode, because that consumes only 500 to 600 kilobit to deliver that user experience in a way, and that is compatible with weaker broadband network.
Okay.
If you have 100 megabit, you can easily go to the video mode.
Okay. All right.
So this is what I meant.
Yeah.
You can adapt the solution according to your bandwidth.
Okay. All right. All right. Well, thanks again, Randolph.
Okay, thank you.